So in the dictionaries, we have discussed that for dictionaries, we have discussed what is again repeated what is mutable and immutability, and what are the immutable and immutable sets in the dictionary. Okay. Just once I will show you the slide because it is important to not to go with the confusion. Okay. So when we're implementing the any project, okay, right? So, so mutability means we can change the content. Immutability means we cannot change the content. So list dictionary set of though the sets are unique, dictionary key values are immutable. These comes under the mutable. And the tuple string and all the numbers we this come under the immutable. Immutable means if you want to change anything, we have to create the new object. Okay, but in the mutability, we can change without changing the location or which without creating the new object, we can add, delete, update the content of the these lists or dictionaries. So coming to the mutable list dictionary sets comes under the mutable, and immutable comes under the strings, tuples, and numbers. Right. So that's what we were. Then we'll come back to our uh, dictionaries, which we discussed in 5 minutes. Right. So we discussed about how the dictionary will be like key and value pair, and in any key can contain any kind of data structure along with the value can be any kind of data structure. Okay, like here allergies are the lists you can see, right? So again vitals are again another dictionary data structure, right? So like that we can use the dictionaries to store diverse non-structured data. No, you know MongoDB, right? MongoDB mostly MongoDB is for the unstructured data, right? So you know the advantages of the. If you don't know, we'll discuss in the next in the coming sessions. Whenever a database is discussed structured and unstructured data. What are their use stages when they are used at what particular case they are used when structured data is used structured that is MySQL or PostgreSQL or SQL when they are used or Mongo when we use and what are the different types of the Mongo databases that and when we use them that we'll discuss in the next coming classes once parallelly along with the Python we'll also discuss the databases. In that scenario we'll discuss all those things. Then we also discussed about adding a value, accessing a value, and modifying a value from the dictionary. So that we discussed, right? And we have discussed about uh, in a real world because we are going to do the robotic and health project. So in that scenario, we're trying to explore that environment in our topic so that we can have ease of doing the project while we go into the project, right? So this is the state representation. Whenever we need to use the state representation or a mod the features of a particular environment, robot environment, then we that is unstructured data. It is not structured. Dynamically we have to, and it is scaling, right? So here in this case, we have to depend on the this dictionary, and in the healthcare also to represent the patient data, we have to depend on unstructured data. Okay, so that's what you can see. Here medications you can see it is a list of dictionary. It is a list of dictionary objects. It is a list of objects, right? So this list contains the first object of dictionary and second object of dictionary. Okay, so like that, when we have a complex structure of the data, unstructure of the data, we use the dictionary. Okay, then we discussed about the set. So set is unordered collection of unique elements, right? So it need not be uh, ordered, but it's like a list where every element is unique and the order doesn't matter. Okay, so here the key benefit of the sets is their incredible speed of checking if the item exists in a collection or not. So for clustering or few concepts, we use the sets where we consider everything in terms of the uniqueness, and uh, here normally, where do we use the union while in a set? Where do we use the intersection? Where do we use the difference? Like that, right? So say you want to know, so you have you are doing a course. There are normal core cones, core something. In that, you will be having a confusion, right? So what you can do, you can the confusion. Why you are getting the confusion? You need to know what are the subjects which are common in both, right? So what you have to do, you have to perform the union operation, right? So even health cases, health department. Okay, you are getting a frequent patient in a particular timing. Then what you'll do, you need to find what are the common scenarios, common features where patients are having union of that, right? So like in such cases, we'll use the union intersection and difference. Where do we use the difference? Where do we use the intersection? Right? So those things, whenever they are needed, mostly we use the sets in those cases. So main key properties of the sets are they're not they do, we no duplicates are there. So whenever you add a duplicate item to the set, it is simply ignored. Say you are having a huge data set. In that, you want to remove the duplicate. Then what you can do, if you typecast that into the sets, what happens? It will automatically what it will do? It will automatically delete the repeated content, right? So here you can see the names are there, Alice, Bob, and again Alice is there, Charles is there. So you want to remove the duplicate. Okay, in that case, simply what you'll do, you will typecast these names to the set and store in the unique names. What happens? Sets of names, then it will provide the only the unique value. Okay, and the same manner, adding and remove, you can use add function and remove function like you are using in the dictionary. Okay, so right, coming to the robotic and AI platform of managing a unique item. So in a navigation program, a robot might need to track all the location it has already visited to avoid the getting stuck in a loop. So if it is trying to move, and we should see that it should not go into the loop, right? So what we have to do, we have the visited locations we have to create using a set. Then what happens? Only unique values will be stored, or whenever a new visited location is added, if it is automatically it will ignore. So like that, when we can create a set of data structure for visitor location because it uses the uniqueness. Okay, so that we discussed, and even for the patient conditions, group conditions, that you mean to overcome the unique and what is the intersection between the two groups? What are the, say, group A is having the hypertension, diabetes, and asthma. Group B is having the diabetes, obesity, and arthritis. So to find the conditions shared by both groups, we use the intersection, right? So here union is like uh, uh, whatever repeated, it will be removed. Only the common thing, it will repeated content will be removed, and the only one set of the common thing will be there and others will be as it is, right? So intersection means only we will find the common thing only. Others will not be considered. So here we want to know the common values, right? How will do group A conditions dot intersection of group B conditions. Then it will show us what it is there. Diabetes is common in both, right? So that will be shown. Then we'll try to find the condition unique to the group A. Then we'll use the difference. Okay, that means which are not in B, which are in A but not in B. Then we'll use the difference, right? So from the A characters which are not in B, what are these? Diabetes also is there in the B. So only will get hypertension and all, right? So like that, in such scenarios, we use this sets. We'll try to execute that also. So primary, feature in a feature difference between the dictionaries and tests is primary goal to storing the association. Okay, we use the dictionary, and when we want to storing unique items, we use the set. So when you are finding the association, you use the dictionary. Okay, and when you use the set, you will use the when you are having the unique items, you use the set. Then coming to the data access, so you will be having the my dictionary. So by index of the key value, you will be getting any value, right? So using the item in my set, normally in for loops and all, will use the set, right? Then so it is ordered from Python 3.7. It's not ordered. The sets are not ordered. So we have discussed, right? Use case examples are robot state in dictionary, patient records, and model configurations. All this comes under the dictionary set, right? So coming to the dictionary database, robot state, patient records, and model configuration comes under the dictionary. And sets, visitor location, unique identity, vocabulary list, all these comes under the set. Okay, so here which is best for what? Okay, so dictionary is best for efficiently retrieving data by unique identifier. Okay, and set is to test a membership, that using the in, if any some item is there in some list or not, or for deduplication, to remove the duplication. In those scenarios, we use the set. And when we use dictionary, to retrieve data by the unique identifier. So that is best for dictionary. Okay, so these are the two things which we need to discuss. And a rule of thumb is, if you need to store data with a label for lateral retrieval, use the dictionary. If you need to track a list of unique items, that means the existence of an item in some list, some group of items, then we use the set. Okay, conclusion is dictionaries and sets are more than just data storage. They are fundamental tools for building efficient logical applications. So to run an efficient logical application, we use the dictionaries and sets. Okay, example we have discussed. So let's say names, it should be unique, right? So sets name, because it is I am having up to 8 only. So we'll have tomorrow completely. We'll have a practice because my system issue. So functions, as you know, it's a block of organized reusable code that is used to perform a single related action. So whenever you want to execute a block of code number of times, wherever it is used by calling it, then you go with you'll save that code block of code in a function, and what you will do, wherever you require, you will be calling. Okay, so in that we will be having two things. One is defining a function, and calling a function. So in the Python, defining the function is very simple. We use the def keyword, function name, anything like display or any name you give to the function. Then parameters. Then code will start after the column with a indentation. As I said, for loop and while loop, we will be having indentations, right? In the same manner, these indentations here we will use for the function block. So whatever we write with this indent comes under this function. So this is a definition. So definition already we'll write only one. We'll use this function, call these functions many times. So here definition always starts with the def, right? And function name, the parameters. Parameters means if you want to pass something, you want to add two numbers, then you will be passing those numbers, but while you are calling, right? In that case, you will be where to store that passed value. Here in the signature, they will be passed, and here it will, whenever there is a call, in these parameters, the passed value will be stored. So here, this function, what it is doing, it is when we send two values with this function, those two values will be stored in result and it will return the result. So wherever it is called to that place, it will return the result. So here, Divya, my screen is visible, right? Divya.
Sir, it is visible clearly, sir. It is visible.
Yeah. So whenever it is not visible, immediately tell me. Okay. Don't waste the time. Okay. Then these two, if I 10 and 20 is there, 10 and 20 will be added and stored in the result, and it will the 30 will be returned wherever it is called. So this is the body of the function. This is the name of the function. These are the parameters. This is the keyword. It specifies that this is the function of the function. Right. So tomorrow we'll be having the execution part. To call the function, see here, we are simply calling function name 10 and 5. So what happens is 10 will go to the first parameter 1, and 5 will go to the parameter 2. And what happens, both will be added and stored in the result, and this result, what is the 10 and 5 added, 15 will be stored in result, and this 15 will be returned. So where it will be returned, where we are calling. So here we are calling. To this place 15 comes. Okay. So this will be, this code will be executed. This is calling. This definition will be executed, and here 15 comes. And 15 will be stored in with some result. So, and when we are printing, the output will be 15. So once we define, we can call a number of times. This is called calling. This is called definition. So we will define only one, and we will call many times. When we are overloading, in that is separate definition. Name may be same, parameters different. So function parameters and return values are the variables listed inside the parenthesis in the function definition. They act as a placeholder for the values the function expects to receive when it is called. So in a health industry, like say we want to calculate a body mass index. So you are getting the result, and the machine is checking your body mass index. How it will check? It will take the parameters like weight, height, and some other which are used, and it will calculate the body mass index, and it will throw the output. So for that, we'll simply define a function called calculate BMI, and weight and height will pass. Then automatically it should return the by calculation, right? By taking these values and calculating the BMI, and it should return that result, right? So here you can see if height of M is less than 0, okay, handle invalid height, okay. So it should not be 0, right? Otherwise it will be the wrong one. Then how the BMI is calculated? Weight of body mass index is calculated. Weight slash height starts with. Then what happens? It will return the value, right? So here, if your patient weight is 70 kg, patient height is 1.75. So this function, okay, what is that? For to calculate BMI, we'll send 70 and what is the height is 1.75 centimeters. That's the same, right? So when it is we call it 1.75. Then this all will go to the definition here. So what the definition is doing? It is checking the first is less than or equal to 0 or not. It is not. If it is not, if it is less than or equal to 0, maybe. So if it is less than or equal to 0, what it is doing? It is returning the 0. Because it is wrong, right? Why we can't calculate using the 0. So then, if it is not, then it is going to this. First, you take this condition, not 0, then it will calculate the BMI and return the BMI. So that returned BMI will be stored in the DNA value and it will be printed. So that is an simple example for uh, health. And for coming to the robotics industry, the function that determines the optimal gripping force for a robotic arm based on the object. This scenario will see, and tomorrow we'll go for execution. Today I'll explain. So in this, everything is written in the code. That means it won't work. So this is the explanation of the code. So what is the main use of this function? It determines the optimal gripping force for the robotic arm. So based on the weight, it has to grip, right? So for that, to call this gripping force calculation, we have to send the object weight. So how we write the code? Here we can see in writing, if object weight is less than 0.5, that is off stage, then return light gray. If else if it is between 0.5 and 2 comma 0 to 2 kg, then return medium gray. And vice versa, you will be writing. And what you are returning, you are returning the key to the this function as a result, right? So that return value is considered, and the code will be changed. Either the robotic arm which will be a light grip or medium grip, how it will handle, that will be uh, based on this. So if it is less than 5.5 light grip, it should return. If it is greater than half kg and less than 2 kg, it is medium grip. And if it is more than that, strong. So say we are and we are finding the value is getting over. Then what it will return? It will return to this distance as uh, medium, right? Medium grip. So that medium grip is will be given to the next function as an input, right? To hold the any value. So here you can see, based on the weight, the hand should have the grip. If more weight is there, it should hold tight. If it is less, it should hold little loose slightly, or in a medium or a tight. So we'll write different functions. For that, we can write the function like. So here we are writing a get gripping force and object with the object weight. Okay. Right. So Divya, it seems I'm having a session at 8:20, right? No, 8:20 or 8:30.
Sir, 8, sir.
Divya?
8 p.m., sir. Sir, 8 p.m.,
No,
sir.
no, no. They said he said at 8:20 it is.
No, sir. 8 to 9, sir. Another session.
Okay, someone go to that session. Please tell the candidates to wait for 10 minutes. Okay, but in that,
Okay, sir.
that was 8:20. But anyway, someone go to that session, attend the session, and tell the candidates to wait. See, this example which is path finding in a grid. So say a grid is like this, okay, where you can see to check is there any side path to destination or not. So for that, say this is the grid will be considered like. So we'll see an example. Whenever a robot wants to move from this place to this place, how do we write a function to check any obstacle is there or not? The blue items are obstacles. The white are there is no obstacle. So when there is an obstacle, it is considered with the 0. When there is no obstacle, it is considered with the 1. So this is represented with a list of it. You can see. Yeah. So like this, using the list, whenever there is no obstacle, it is represented with the 1. And whenever there is a obstacle, it is represented with the 0. So this grid, they are represented with the list with x and y coordination, right? So tomorrow we'll have an example. Tomorrow I don't want to extend the topic, only the execution will discuss. So tomorrow we'll try to write a function where to check obstacle in the place. What is this place? Actually, if you're talking in terms of the x and y, x coordination 0, y coordination 4, right? So in that case, first thing, basic thing we need to check is we need to while the robot is moving, it has to check the obstacle there or not, and it has to move. How it will move? If it is there, what are the coordinates? X 4 x is equal to 0 and y is equal to 4, right? So this is 3 and 4. X coordinate is 3 and y coordinate is 4. So from this to this, how it will move? Y it need not to change. X coordinate it has to increase 1. First x coordinate is 0, then it will become 1, and it will become 2, and it will become 3. In this scenario, what happens? We'll use for in loop and move object from here to here, right? So that we'll discuss tomorrow. So we'll repeat the sets and functions tomorrow. We will only execute the code. Okay. Okay. Thank you very much.